So here's the Polytec Laser Doppler Vibrometer. You can see the optical path here. Starts right here at the laser, goes around through this prism, then this prism, then a backscatter to another sampling prism that goes to a photodetector, through a Faraday rotator, which is an isolator, a flexure adjustment into the fiber optics, and then it goes down the fiber optic line right here. Comes to the probe head, which has the AO modulator, which modulates or frequency shifts the laser beam by about 35 megahertz. You can see that here. We're listening to the output of the reflected signal in single sideband mode, so we can actually hear the FM, low frequency FMing of the signal. And here's the laser beam. It's pointed at this tablet of paper here, so you can see here's the sensor head, and I can put my finger in front of this. And so what you're hearing, that noise right there, is actually the table shaking. I'm just barely touching this. And then if I move my feet any at all, you hear that. So that's the Laser Doppler Vibrometer. This is a CLV 700 head made by Polytec, and this is the CLV 800 laser head. And then this is the laser itself. And you can see the fiber optic feed right here. It goes into an armored cable, which is much heavier right here. This is the 35 megahertz output from the heterodyne signal, or the frequency shifted laser. And that goes over to my FM receiver, which is essentially tuned to the same frequency as the acousto-optic modulator, which is in this unit. So I just wanted to demo how that works.